reference to one of the object in binary system and find out what is the angular velocity of the other object in this frame of reference. Let's see the animation first. So here we have our binary system having object P and object Q. The mass of object P is small m and the mass of object Q is capital M. The object P is moving around in a circular orbit with angular velocity omega. Now if we fix the frame of reference at object P, so this frame of reference is accelerating because a centripetal acceleration having the value r omega square is always acting on this object. So in this frame of reference, the forces which is acting on object Q are capital F, which is mutual force of attraction, and a pseudo force which is capital M times centripetal acceleration of object P, that is r omega square. Now for an observer with object P, the object Q will appear to move around a circular orbit with angular acceleration omega dash square. So these two forces are responsible for the centripetal acceleration of object Q. So this will be equal to m into capital R into omega dash square. So from here we can get the value of omega dash square, which will be equal to F plus mr by mr, or omega dash is root under F plus mr by m into capital R. So let's see the animation first. So here we have our binary system with having object P with mass small m and object Q with mass capital M. Object P is moving around a circular orbit with angular velocity omega. So the centripetal acceleration of object P would be r into omega square, where r is the radius of circular orbit around which object P is moving. Now let's fix our frame of reference at object P. So in this frame of reference, the forces acting on object Q would be F, that is mutual force of attraction, and a pseudo force which is equal to mass of the object Q into centripetal acceleration of object small m, that is m into r omega square. So these two are the forces, that is F plus m r omega square, which is acting on object Q in the given frame of reference. Now these two forces are responsible for generating centripetal acceleration for object Q. So if in this frame of reference the object Q is moving with angular velocity omega double dash, then this will be equal to m times a into omega double dash square, where a is the distance between object P and Q. So here we can write omega double dash square is equal to F plus mr omega square by ma, or omega double dash will be equal to F plus mr omega square by capital Ma. Now we have already seen that if these two objects are moving with angular velocity omega and omega dash, then omega was equal to omega dash, and m into small r was equal to capital M into capital R, and r plus r was equal to distance between the two objects, that is A. So from here we got r into 1 plus m by m is equal to A, or r was equal to ma by m plus m, and small r was equal to capital Ma by m plus m. Also the force which was acting upon these two objects was F. So for object P, F was equal to mr omega square, and for object Q, F was equal to capital R into m into omega dash square. So from here the omega square was equal to capital F by mr, or omega was equal to capital F by mr root under. Since omega square is equal to capital F by mr, we can put the value of omega square here. So omega double dash square will be equal to F plus mr into F by mr by ma. We can cancel out r here, so what we have here is capital F into m plus m by m into small m by a. So this is the value of omega double dash, that is the angular velocity of object Q in the frame of reference which is fixed at object P. Now let's see what is the value of omega and omega dash, which is the angular velocity of object P and Q respectively in a inertial frame of reference. So as we have seen that omega was equal to F by mr. Now value of r is nothing but m into a by m plus m. So if we replace the value of capital R, we get omega is equal to F by mma into capital M by m. Similarly, we'll get the value of omega dash, that is the angular velocity of the object Q in an inertial frame of reference. So as you can see from here that the value of omega dash and omega double dash, they are equal, and it is equal to F into capital M plus small m by capital M into small m into a root under. So this is one interesting result that you need to remember, that even if we fix the frame of reference in at one of the object, the angular velocity of the other object will remain same. Now we'll start the introduction of